Well, hello again everybody, and welcome back to this rat's nest of wires. Well, I've just wired up the MSD6 electronic ignition, and just to give you a quick overview of what we've got here, we've got thick power wire here. This is carrying the main 12 volts which supplies the electronic ignition. Got a thick black wire, this is the ground connection. We bodged in a temporary fuse here, which is this black thing down here. Got a couple of connections here, which is a purple and I don't know, purple and green. That's used for a magnetic pickup coil, which we're not implementing today. We've got the voltage, the high voltage coil here, which is just basically a step-up transformer. That's this thing here, and I've just installed a little piece of wire between the neutral, the 0 volts, and the secondary high voltage output of the coil, because I'm hoping we're going to get a spark jumping across there if everything's working. And we've got a switch that I've installed down here, which is actually replicating the switch that would be inside your distributor, because basically if you open up a distributor on an old car, I think we talked about them last time, you'll find a set of points that open and close, and the purpose of them points on this circuit here is that when those points close, it pulls this white wire down to ground, and that initiates this electronic ignition from doing its thing. And just a reminder of how this works, this is an electronic ignition system, and it's slightly unusual in that it doesn't just switch 12 volts on and off to the coil, it actually switches 400 volts to the coil. So we've got a little inverter circuit here, you can see the transformer. So the way it works is that we've got a transformer, and that steps up the 12 volts to 400 volts. That charges up this big 600 volt capacitor here, and then that capacitor gets discharged into the coil, and hopefully if all that's working we should get a big spark across there. So I've kept you waiting long enough, so well, I guess we've just better give it a go now. So if I press this button, hopefully you're going to see a spark over there. 1, 2, 3. Oh! So we're definitely getting something, and I can tell just from looking at that, the you know, the length of that spark there, that's a more powerful and high voltage spark than you would get from a, you know, a combination than a normal ignition system just using a coil and set of contacts. I've played with enough cars, I can just tell by looking that that spark is hot enough, it's got enough current behind it and enough voltage to jump that gap. You know, you remember when you were under the bonnet of your old Princess or your Austin Allegro, and the spark that you would get off the ignition coil was, well, sometimes it was barely powerful enough to jump across the spark plug gap. And I've actually got a spark plug here, so you can, I don't know if you can see, the spark plug gap there is, well, I don't know. It's about the thickness of my thumbnail. That's what the gap is between the centre firing electrode and the ground. Well, you can see that we must be an orditude of magnitude. We must be 10 times the gap of a normal spark plug. Our spark is jumping that with ease. Let me bring it in so you can fully appreciate the awesomeness of this spark. Are we ready? Easy whizzy, let's get busy. I'm going to try and press that switch as quickly as I can to try and replicate a real set of points opening and closing, but I don't think I'm going to be anywhere close, but let's have a go. Are the transistors getting warm? No, totally cold. One of the things about this ignition is that it's what they call a multiple spark discharge. So I don't know if it comes across on camera very well, but that spark that you see in there, every time I press this button, you're not actually seeing one spark, you're actually seeing a number of sparks. And the way that this is done is, I said, we charge up this capacitor, and then it uses a multi-vibrator circuit to discharge into the coil multiple times, and that's where you get the MSD. So it's multiple spark discharge ignition, lots of sparks as opposed to just one spark that you would have with a conventional set of electromechanical points in your car. A couple of things I would quite like to know. I would quite like to be able to demonstrate that multiple spark discharge, and just for my own interest I'd quite like to see what voltage level we're at. This could all end up in tears. Let's have a go at measuring that. So I'm hoping you can see this. What we're going to be using to do that test is my BK Precision high voltage probe. Well, apparently it's not a high voltage probe. I think I pointed this out last time. Apparently it's a 1000 to 1. It's a voltage divider probe, spelt VALT. So yeah, we've got a little bit of Chinglish escaped onto the front there. And yeah, high voltage probe. What does it look like? Looks like that. Way! And you may also have spied at the back of my bench this old Tetronic scope. Well, I say old, I suppose it is old. It's God, doesn't time fly when you're having fun? It's probably getting on for 20 years old now. But this was my first, what you might call, high-end scope, or it was certainly high-end for me. And yeah, I like this scope. Still got a lot of love for it, but I haven't used it for a while, so I have to figure out see if I can remember how to work it. I think I'd like to get this running a little bit more like a real ignition system to give it a little bit of a test, and I am going to do a bit of a soak test on this. Now obviously I can't press this switch fast enough here. I can't actually click that in and out fast enough to replicate a real set of points on a car. So what we've done here, I've just set up a little circuit here, which is just an open collector NPN transistor, and we're just using that to allow my signal generator to initiate the pull down signal in place of this switch. So hopefully you can see that my old TTI programmable function generator, and at the moment that's set to, well, let me have a look. I can just see that it's set to 10 Hertz. So in theory, if we well, not in theory, if we actually turn the signal generator on, it should produce our spark at about 10 times a second. So let's have a go. So switching on now. And there's the trigger signal that we're putting into it. Now I do wonder if we could actually see the trigger signal and discharge on the same scope display. Let's just try that. And let's see if anything's getting warm at that. Now these are just above ambient temperature. They're not hot, but they are warmer than they were. So yep, them transistors are happy. They're definitely doing the job. So I think the next thing to do is let's simulate it running in a real car, or a real truck in this case. So we need to increase that input frequency. Well, this ignition system is going to be installed in an old American truck, which is a 6-cylinder engine. That's what it uses, and it's quite a slow running engine. So kind of, if you do some quick and dirty maths, for a 6-cylinder engine running at, I don't know, let's call it 3,500 RPM, I would have thought that's not an unrealistic speed for it. So if we do 3,500 revs per minute, you can kind of do the math on that, and you come out with a frequency of about 170 Hertz. So we'll just put that in, frequency 170. Now when we were looking at the trigger waveform earlier, you could see that I was using a square wave. Well, that's not particularly correct, because it's kind of a pulsed output from a real set of points in a distributor, because they have something called a dwell angle. So basically the mark to space ratio is not symmetrical. You get comparatively short pulses, so you get a short mark and then you get quite a long space. So it's a pulse waveform. I'm sure I don't need to explain that to you. I think my audience probably play with cars as well, so you know all about that anyway. So we can't quite generate that, well, not without punching some more numbers into the signal generators, which I can't be bothered to do. Okay, what you'll want to see is me switch it on, isn't there? So let's switch it on, and this should be a lot more exciting, hopefully. 1, 2, 3. Ooh. So we're drawing about 3.5 amps, 4 amps there. And I've got a really strong smell of ozone in here. So I wonder if the current limit was coming on there. Certainly the voltage appeared to be dropping, didn't it? I'm not sure what the current limit is set to on this. Set to 5 amps. Let's increase that. I guess in the truck it's going to be fused at 15 amps, so let's see if that makes any difference. I'm a bit scared now. Some poo may come out. Oh dear, that is seriously violent. These output transistors are getting hot to the touch. So I think I'm pretty confident there that everything is working on this ignition system as it should. So I had a word with my friend Andy, and he did confirm that when this unit originally failed, he thought it could have been the fuse that had blown. Well, he checked the fuse had blown, and he didn't have a replacement fuse, so he did just put a piece of wire in to see if it was the unit that had failed or just the fuse that had blown. I think the way he looked at it, he had nothing to lose because it didn't work anyway. And he tried it, and it didn't work. I have been trying to get hold of the correct inline fuse for this, and basically you can't get them, or I couldn't find anywhere in the UK that did a 15 amp inline fuse. You can get some 15 amp fast blow fuse, but I don't think that's what this would have been. So what I'm going to try to do is I'm going to try to change it. Now there's no room to actually install a different type of fuse on the circuit board itself. So what I am going to do instead, I've bought from, just from Halfords actually, I've just bought a traditional inline fuse, and I'm going to solder that fuse, one end of it, into the board here, and I'm going to join the incoming red power wire to that inline fuse, so it will have a proper fuse inside it as opposed to not having a fuse. I'm handling everything a little bit gingerly because it was only about 10 minutes ago I had this switched on, and I'm kind of wondering if any of this circuit is still charged up. And of course you'd probably say, well, why don't you just go and discharge it? Well, it's actually not that easy because everything's that thickly covered in conformal coating. It's not actually that obvious what you would be discharging, so I haven't done that. Here it is, Halfords Special. Actually, I normally bitch and moan and complain about the prices of Halfords, and to be honest, it was about the same price as buying this from Halfords as it was buying it online. So yeah, I'm not complaining. Has it got a fuse in it? No, it hasn't. So I did also buy some fuses as well. Let's hope I bought the right size. Will that fit in there? Hopefully it will. There we go, 15 amp fuse. So if my friend Andy is watching this when you get stranded next to the road, this is where the fuse is. And you don't need to solder a resistor leg across it next time, because if it's going to blow, it's blowing for a reason. There she blows. I'm hoping my soldering iron will be powerful enough to actually solder this wire in, because it's quite a big wire. I was just taking a little break before, and the other thing I've just checked is that the tabs on the transistors don't require any isolation pads on it, any insulators, because I was a bit worried that maybe if it had been dismantled in the past that somebody had taken them out. Well, it doesn't seem to be the case. These transistors, these TIP 36s, they're the PMPs. And the centre pin is connected to the back can. It's connected to the heatsink on them. But the centre pin on here, unlike some transistors, it's not the base. It's the collector pin, and that's tied to ground. as is this box. So obviously what I was concerned about is when I actually screwed this back into its box that the heat sinks would short out on the metal body of the box, which is grounded. But no, they're all at ground potential, so I don't have to worry about that. There's a hole in here that I'm trying to get the wire through, but it's not a plain hole, it's actually got a bush in it. Must be a little copper bush or something like that. And it seems that this wire is just a little bit too big to go through. Although it will go through before you tin it. So we're going to have to solder that on like that. Fingers crossed that my soldering iron will do it. Hopefully it will. Yep, done that. No worries. And where the fuse originally was, which was there, I'm just going to link that out with, I've just cut the leg off a resistor, so I think that's what it had in it before, so that's what's going back. Okay, I'm happy with that. As happy as I ever am with anything, which isn't saying much. Because I am a miserable bugger at heart, I'm afraid. So we've got a nice big fuse there, and now all we have to do is to crimp that back onto the incoming mains wire. Sorry, incoming mains, incoming, what do you call it, incoming 12 volt wire. So here's our original 12 volt wire. We're going to crimp that onto there. And that's an adhesive heat shrink I've used, heat shrink shroud, so that the glue inside that should really melt onto the wires, which is going to help stop it from getting damp or contaminated. And it's also going to glue the connector together to give it a bit of mechanical strength. Well, there's a couple of screws that went through these switching transistors. Not exactly sure what them transistors are for. I've got to put them back in because I thought that they were screwed through into the aluminium cover, but they're not. There's some nuts behind them, so we need to screw them back on. Huh. Well, that's annoying. I didn't put a lot of force on there, but the top of the bolts broke off. Oh dear. Hopefully I can get at the nut under it to get that out. Bloody thing. Okay, so we've got everything bolted down now, so what I'm going to do next is I'm just going to replace any conformal coating that I might have damaged. Do not drink. Yeah, I wasn't planning to. Yep, no instructions, useless. Right, okay. Oh, lots of horrible chemicals, heptane, acetone, blah blah blah. Do not drink, do not feed to fish. No. Oh, it doesn't smell as exciting as I would have hoped. Basically anywhere where I might have soldered through or upset the original coating or cleaned it off with acetone, I'm just putting some back on there. It's definitely not as thick and gooey as the original stuff that was on. Actually, it feels quite thin, this stuff. I was hoping for something, you know, a bit more like the consistency of the, you know, the original material that was on it, but well, it's what we've got, so it's going to have to do, I'm afraid. Now, one of the things I was quite concerned about was getting these transistors that are in here at the right height, because we're going to put some screws through the case. And yeah, I actually had them transistors in and out about 4 times previously, trying to line them up with the holes, and well, not had them in and out, but you know, I had to adjust them. And it's very tight putting this back in here. Yeah, don't know why it doesn't go down easily. I can't particularly find anything that it's hitting, but it really doesn't like to slide in. Right, there it goes. Yep, that one's gone in. see if the other one will line up. Am I going to get lucky? Well, looks like we did get lucky. Okay, I think that will probably about do. Right, I'm going to attempt now to get these nuts on here. That should be okay. And now I seem to think one of these nuts was missing from the start, so that's a little bit annoying. I'm going to have to try and find something that fits. And I think they're Imperial, and yeah, I don't know if we'll find anything, so we might have to end up replacing that one. You know, as always, there's always some annoying wire or something in the way, isn't there? Okay, that's going up. And if this works, I'm going to lock everything down with a bit of conformal coating on it, just to make sure nothing comes undone. When we actually took this apart, we did comment that some of these wire placements are really poor, particularly the way that this there's an orange wire here, and the way it's routed, it gets trapped on the top of this transformer, and there's actually no clearance between the top of the transformer and the box lid. So what I think we might do is, I think we might cut this back a little bit, because then the wire can take a better routing, because otherwise it gets trapped on the top of the transformer there, and you know, it could crush the wire. So let's trim this back a bit, because maybe I can route it a bit more. Here's the bit I'm absolutely dreading, trying to get this split collar into here, because it was an absolute swine to get it out. So I'm kind of thinking it's going to be an absolute swine to get it back in again. It really does feel like the you know, the wires are just too thick. It feels like there's too many wires going through here, and I just can't think of anything good to say about it. It is horrible, this this gland. Just doesn't seem any like logical way of getting all these wires into here. It's not even close. I don't know if something's been modified, but it just feels too tight. However you try and pack these things in, they really don't want to go down there. Oh. Absolute bugger, come on. A lot of swearing going on here. Right, that is very tight. I didn't enjoy that at all. Okay, so we've got it all back together now, and I guess the last thing I need to do before I give it my friend Andy back is just to soak test it for half an hour, because you know, this ignition system's got to survive driving to Le Mans and back, which is quite a way in an old 1960s pickup truck. Yeah, I think I'd better test it for an hour or so. It's actually quite a frightening piece of equipment, this. I have to say, I've got a grudging respect for this, well, a lot of respect for this MSD ignition system. It's certainly capable of outputting a considerable amount of voltage through the coil pack, and producing quite a frightening spark. So I'm going to leave this soak testing now, and I'm going to you know, just keep an eye on the transistors, see if I can feel anything getting hot, and if all's good, it can go back to my friend Andy. So let's get on with the testing.